A warm good afternoon to all. I'm Karthik, Assistant Professor, Mechanical Engineering Department from SNS College of Technology. In last two videos, we can see about hardening process and normalizing process. In this video, we are going to see about tempering process. This is the process which is like a post heat treatment process for hardening. So the tempering is a heat treatment process used to improve the toughness and ductility of hardened steel by reducing its brittleness. So this process involves in heating and quenching to a temperature below its critical range, holding at a temperature and then cooling it in air. So the purpose of tempering is that first one is reduced brittleness. So quenching can make steel extremely hard but also very brittle. So tempering elevates this brittleness, making the material more suitable for practical application. Increased toughness, the process enhances the toughness and impact resistance of a steel and allowing it to absorb energy without fracture. Adjusting hardness, tempering allows for a fine tuning the hardness of the steel to match specific application requirements, and relieving stress. It helps in relieving internal stress induced during the quenching process, reduce the risk of warpaging and cracking. So in this type of tempering, we have the following steps. First one is heating. The hardened steel is heated to a temperature below its critical range, typically between 150 to 650 degrees Celsius. And this exact temperature depends on the desired properties and alloy composition. For example, in low temperature tempering, it's around 150 to 150 degrees Celsius to 300 degrees Celsius to maintain high hardness and improves toughness only slightly. While higher temperature tempering is 400 to 650 degrees Celsius, significantly enhances toughness but reduces hardness more substantially. In soaking, the material is held at a tempering temperature for a specific duration, usually ranging from 1 to 2 hours. This allows the transformation process within the steel to complete. So the soaking time depends on the size and thickness of the material as well as the desired mechanical properties. Cooling. After a soaking period, the material is allowed to cool, usually in still air. So this cooling is much slower than the quenching and does not induce significant internal stress. Microstructural changes. The first one is martensite transformation. During tempering, some of the carbon atom in the martensite structure precipitates out, forming carbides. So this process reduces the internal stress and brittleness of the martensite. The formation of tempered martensite. The resulting structure called tempering martensite consists of a ferrite, relatively soft and ductile phase, and finally dispersed carbide particles. In the structure provides a good balance between the hardness and toughness. So reduction in retained austenite. Any retained austenite from the quenching process can transform to more stable phase, further stabilizing the steel. So effect of tempering temperature in low temperature tempering is 150 to 300, produces a steel with high hardness and moderate toughness, typically used for cutting tools and wear resistance application. In medium tempering temperature, which is 300 degrees Celsius to 450, resulting in good balance of hardness and toughness, commonly used for springs, hand tools and certain machine parts. In high temperature tempering, provides maximum toughness and ductility at the expense of some hardness, suitable for components like automobile parts, structural components and heavy duty machinery parts. So in application part of tempering, first one is tool manufacturing. Cutting tools, dies, punches often requires tempering to balance hardness and toughness, ensuring that it can withstand operational stress without fracturing. Second one is it is mainly used in automotive and aerospace components as part like gears, crankshafts. Structural components are tempered to endure high stress conditions while maintaining durability. The third one is in spring and fastener productions. So the spring and fasteners required specific composition of elasticity, strength and toughness, achieving through precise tempering. Construction equipments, the tempering components in construction machineries such as excavators, teeth, wear resistance parts benefits the enhanced toughness and reduced brittleness. Tempering is a critical step in heat treatment of steel, allowing the customization of material property to suit a wide range of industrial application. By carefully selecting the tempering temperature and duration, manufacturers can optimize performance characteristics of their products.